quickly to some of the machine learning definition. There are quite a number of definitions. I can list out a few over here. So the machine learning is a major component of data science. As I said, data is the underlying principle. Machine learning is the study of computer algorithms that can improve automatically through experience and by the use of data. So these definitions I've already said. The last one is machine learning is building useful models from data. Okay. So now, like, can I, all this sounds simple. I feel that, okay, I can collect data, I can collect, clean, curate, everything I can do. But is it that simple as it sounds? It is not. We need to have certain skills. And what are the skills required to become or to have machine learning knowledge? So machine learning is basically built on foundational advances in mathematics and computer science. So if you are strong enough, you have good computer science background or maths, then you can very well go for this. And linear algebra, it is actually the pillar of data science and machine learning, and together with optimization and statistics, and also regression. Regression is a part of statistics. It's a major part of statistics. So if you know all of these technology, all of these skills, you know maths, you know computer science, you know linear algebra, you know how to optimize, you know statistics. If you know all of these, then this is very important, very easy to learn. Okay, I'll just quickly talk about the difference between the traditional approach and the machine learning approach. So in traditional programming, as we all know, we have certain inputs, and we give the program so that we get our desired output. Whereas so in traditional, we have hard-coded rules, but then for machine learning approach, we do not have hard-coded rules. What we do is, we generalize the model. So we give the data and the output, or the predictions or what we want, and we actually make the algorithm, or program is what we want. And this model is trained with a set of training data in order to learn the algorithm that best explains the model. So it is actually a human guided exercise, I can say. So it is the human which comes in picture, and it is the human which is going to decide on what algorithm or the architecture which I have to use for this particular set of data, so that I can get the most precise output or the perfect model I want. So this is the difference between traditional approach. We give data and the program, but there we just give the data, or I can say the input and the predictions, which will give me a algorithm, or the model which is trained on this data. Okay, so quickly talking about the types of machine learning also. I hope in your coming up sessions, you'll be having more detailed mathematics of all of these. So there are two basic distinctions of machine learning. It is supervised learning and unsupervised learning. We do have one semi-supervised as well. So supervised, as I say, it is, there will be an expert who has labeled the data with the outcomes, or we have labeled training data. Or in other words, I can say that for a specific set of input, these are the outputs. Say, for example, if I have a set of pictures with cats and dogs, which are labeled by some experts. So in future, what this algorithm has to do, it has to label a new picture as an expert would have done. That is what machine learning is. So I will be labeling and giving it, and we train it. And in future, when I give a picture, then the algorithm should be able to label it as a human might have done. So if data comes in categories, or categorical data like cats and dogs, we call it as discrete, and then that is called classification. Or this is a huge area, so I'll talk about that. If the data is continuous, then it is called regression. I can tell you an example like this. Predicting the temperature. Temperature is not discrete. It is like it can vary from, say, if you have a colder region, you can even have very low temperature. So if the data is continuous, then this technique is called regression. So the next type is the unsupervised learning algorithm, where we do not have an expert, or we do not have labels. So here also we have two parts, like the discrete data and the continuous part. So if I have categorical data or discrete data, then the algorithm is termed as clustering. And if I have continuous data, we call it as dimensionality reduction or pattern extraction. So like in clustering, what they do is if the pictures of cats and dogs are given, it will learn the distinguishing features of the picture. It will identify the features of those images. And in dimensionality reduction technique, it is a way of converting this high dimension data set into low dimension data set and ensuring that it provides similar information. So each of these four areas, like the classification, regression, clustering, and dimensionality reduction, are huge areas, and a lot of research is going in this area. There are a lot of textbooks. There are thousands of papers in each of these areas. We have one more type, which is called the semi-supervised algorithm, where we have partial labels. It's like, every image or every data will not be labeled, but there are a few which will be labeled, or it's like some feedback but not all. So we get some feedback from the expert. So the reinforcement learning which we see every day, which is the most emerging area in machine learning, it comes under this semi-supervised learning algorithm. So in reinforcement learning, if you look at, there is an agent and a reward, and there'll be a lot of hurdles in between. So this agent will get a reward for some actions but not all. So agent, what it has to do, it is supposed to find the best possible path to reach the reward. So that is what it is. And there is something else called the generative models also, which comes in here. That is basically a popular neural network architecture that allows you to generate new data, and those data will look like as though it came from the system. Okay, so this is a pictorial representation of all the algorithms. So I could say that this is a rough sketch of all the algorithms. If you look at this sketch, you can see that each of this classification, regression, clustering, dimensionality, reduction, all have a lot of algorithms. So it is the human expert who has to decide which algorithm I should choose for my system or for my model to be perfect. So we have an optimization and control also here, which is basically for supervised and semi-supervised, where we'll try to optimize certain parameters of the system. And we come to quickly to an example. A recent example I want to share with you is Amazon Go. Amazon Go, as everybody knows, it is a chain of convenience stores in the US and UK, and it is operated by the Amazon, online retailer Amazon. So what is it? Everybody might have seen this. The stores, we have stores, and they are cashierless, with customers able to purchase products without being checked out by a cashier or using a self-checkout station. So you just simply walk in, grab what you want, and walk back out. Within a few minutes, you get an accurate receipt for everything that you took. So this technology they have termed as just walk out technology. I'd like to share a video here.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So that is what about the recent application where the technology they have used is sensor fusion, computer vision, and machine learning algorithms. So I have a certain sample course also, which shows the applications of machine learning. I have a small video also to show that how it is not very difficult to program in Python, but then how to detect the face, how to do a template matching. Template matching means to search and find the location of a template image given a big image, and also edge detection. I'll just quickly show you that as well. So this is actually written in Python notebook using Google Colab. And the first one is for face detection. So we'll give a certain image, and in that it will identify the face. So this is what it is. So I'm not going to explain how to write the program or what are the lines of this code. So this is how you do that. The second one is template matching. It means you are searching and finding the location of a given image. So in this picture, you can see there are 5 people, and a template image is given, and it is being identified using that particular program. And if you want to change another person, you want to identify another person, we'll need to change the template image or the input image. You need to change it to another person's face, and you can see that now a new person's face, and it is the technology is that it simply slides the template image over the input image, and it draws a rectangle in the region of the template. And finally, for the edge detection, we use the Fourier transforms, and this image is converted to a frequency domain 1, where the plot will have high frequency and low frequency regions, and using a filter, a high pass filter or a band pass filter, the edge detection can be done. So all of these are certain examples of the course for the application of machine learning. Like, when should you use machine learning? So machine learning, as I said, it should not be like everywhere we are going to use. We'll be using machine learning only when we have the task complex or the problems involving large amount of data and lots of variables, but no existing formula or equations are there. Say, for example, face recognition, handwritten rules and equations are too complex. That time you can use machine learning. You can even use machine learning in when the rule of a task are constantly changing. Say, for example, the fraud detection, and also when the nature of the data keeps changing and the program needs to adapt. There also we can use this machine learning techniques basically for automated trading, energy demand forecasting, predicting the shopping trends, and so on. So as like to conclude, I put all of these in a picture. This has been taken from Google, the machine learning process as a whole. There are 5 steps. You identify the data sets and prepare them for the analysis. We need to choose the right machine learning algorithm. So the algorithm which I have shown you, there are huge research going on, a lot of maths included in the algorithm. So it is the human who decides which algorithm to be used to get the perfect prediction. So the third step is build analytical model based on this algorithm, and you train the model with the data sets, and then you validate. So that's all I have for you. Thank you.